Hi everyone. In this video we'll be discussing about the ACID property in databases. So by the way, this is going to be the high level discussion on all of these properties. And I'll be making two separate videos, one for isolation and one for durability, because they need a separate video on that. Alright, so let's get started. So before learning about atomicity, let's first learn what is a transaction. So assume that we have this accounts table wherein we have multiple users like LS and Bob. LS has $1,000 and Bob has $0. And LS wants to transfer $500 to Bob. Okay. So the database commands would look something like this, wherein in the first step, we would deduct $500 from LS's account. All right. So it would become 500. And in the second step, we would add that 500 into Bob's account, right? So this would generally work fine. But what if your database server goes down between these two steps, that is over here, right? So in that case, Bob will never receive that 500, isn't it? So your money is lost, right? So we want to prevent such kind of scenarios. So first of all, this problem occurred because we were treating this operation as two-step operation, first step and second step. And this is why the database server went down in between both of this step, right? So in order to overcome this, what we can do is we can make use of transaction. All right. What transaction will do is it will make this operation as atomic. Okay, it will treat these steps as one single step, so that even if there is a failure over here, then the database will roll back the changes automatically. All right, so what we have to do in such cases is we have to write this begin transaction command and commit command over here. So now the database ensures that even if it goes down over here, it will roll back all the changes which it has already executed. So over here the balance was deducted by 500, right? So the database will make it 1000 again, right? So this is what a transaction is. It is basically treating all the steps as one single step, right? So now let's see what is atomicity. Atomicity says that in an operation, either all or none of the steps should be executed. So for example, the operation is to transfer money from one user to another user. So in that case, the first step would be to deduct the money and the second step would be to add the money, right? So in such kind of operation, either all of the steps should be executed or none of the steps should be executed, right? So this is what atomicity says. And the database helps you to achieve this atomicity by providing you something called as transaction, which we just now saw, right? You just need to write begin transaction at the very start and commit at the very end. Okay. So I hope you got this point. So now let's learn about consistency. So assume that we have this users table wherein we have multiple users like LS and Bob. And Bob wants to update his name from Bob to X, a one character name. All right. But the problem over here is while creating this table, we have already mentioned that the name should be at least 2 characters long. Okay. So we have defined this constraint over here, right? So what database will do that is while moving from one state to another state, right? Currently, this is the state of the table. So while moving from this state to a new state like this, it will check all the constraints which we have defined. So over here, the constraint, one of the constraints said that the length of the name should be greater than equals to 2, right? Which is getting violated. So database will not allow that operation to succeed, right? This operation would never succeed. So the name will remain as Bob. All right. So this is how the database guarantees us the consistency. Whenever we try to move from one state to another, it will check all the constraints defined by us. Okay, so let's take one more example. Assume that I want to insert a third user into this table. But while inserting that user, I am providing the ID of that user as 1. then also the database will not allow you to perform that operation. Why? Because it will see that ID is a primary key and primary key should be unique, right? So that's why it will throw the error. Basically, it is not allowing you to move from one valid state to another state, which is invalid. Because if it allowed you, then there would be inconsistency, isn't it? There would be two users with the same ID, right? So this is how the database guarantees you consistency by default. Now let's try to understand what is isolation with the help of this example. So assume that you are dealing with some movie booking application wherein only one seat is available for a specific show. And there are two users who are trying to book that seat. Okay. So they both will try to read how many seats are available simultaneously like this. And they both will get that one seat is available, right? Now they both will pay the money simultaneously and reduce the counter from 1 to 0. So 1 minus 1 is 0. And similarly, this user will also do 1 minus 1, which is 0. The problem over here is they both have paid the money for the same seat, right? So this is the problem. So what isolation says is whenever multiple transactions run concurrently, you would face different kinds of problems, that is different kinds of anomalies, which we would discuss in the next video. So there are many anomalies. This is one of them, but we'll discuss all of the anomalies properly in the next video. So whenever multiple transactions run concurrently, you would face multiple problems, right? And database will help you to eliminate those problems by giving you different isolation levels. So they will help you by giving 4 different isolation levels. You just have to use those isolation levels in order to prevent the anomalies which you want. Okay. Right. So under the hood, this isolation level will use different concurrency control techniques like pessimistic, optimistic, MVCC or time-based, whatever. We don't care about that. Only thing we care is database has provided me the isolation level which I have to use in order to prevent problems or anomalies which occurs when multiple transactions run concurrently. All right. So I hope now this isolation part is cleared. However, we'll have a separate dedicated video on this isolation where we'll discuss about anomalies and levels. Now let's learn about durability. So assume that you want to update the name to Bob, right? So if you have seen my previous video, then you might be knowing that all the table data is stored into multiple pages. So let's say the data of Bob is stored into this page. So first of all, when you try to execute this command, that page is brought into the RAM. And over here, you try to update the name, okay? So all the update will happen over here in the RAM. And by the way, RAM is a volatile storage. That is, if you shut down your computer at this point, then all the data which is present in RAM is lost, right? So the first thing is whenever you run a particular statement, it will bring that page into the memory and perform that update. And the second thing it will do is it would also write that command into a log file, write ahead log file like this. Okay. So normally what happens is once it performs the changes in the RAM, it will flush that onto the disk after a few milliseconds or after a few seconds. All right. But assume that before it was able to flush that onto the disk, your database server went down. So in that case, obviously the data which is present in the RAM will be lost, isn't it? But what database ensures is even in such kind of scenarios, whatever query which you have performed and committed, okay, the commit statement should be there. So whatever statement you have performed and committed, that will be basically durable. Okay, so once this database server comes back again, it will rerun this log file. It will re-execute these commands which are already committed. Okay, so I hope you got this point. This is how the database achieves durability because of the log file. If the update was already flushed onto the disk, then it was already durable, because disk is durable, right? SSD or HDD is durable. But if it was not flushed to the disk, then also it guarantees you durability because of this log file. All right, so I hope you got this durability part of databases. I hope now you understood the ACID properties in the database. If you did, then please hit the like button so that this video can reach to more and more people. Thanks for watching.